this is Charlene. We're going to solve and graph this inequality. It actually is an inequality because it has an inequality sign. Inequalities just do not contain plain old equal signs. Okay, so let's go ahead and look at this. We're going to solve this as if there's an equal sign. So we're going to use order of operations, and our first order of business is to probably look inside the parentheses and see if we can do anything to what's inside the parentheses. We cannot, but we can eliminate the parentheses by distributing or multiplying into the parentheses. So that's what we're going to do first. So we're going to have that 3 is still out there, and then I've got this invisible 1 right here, invisible 1, and I'm going to multiply into the parentheses. So negative 1 times 4 is going to be negative 4m. And negative 1 times the positive 1 is a negative 1. And then there's my inequality sign, and then I still have 5m minus 25 on this side. Okay, at that point, we just continue to use order of operations to combine like terms. So on this side of the inequality sign, do we have any like terms? Well, I do actually have a 3 and a negative 1. Both of those are constants, so let's go ahead and combine those. So 3 minus 1 is 2 minus 4m, and on this side of the inequality I have 5m minus 25. I do not have any like terms on the right side of my inequality, so I need to go ahead and start moving things to the other side. Like I said, we still treat it as if the inequality sign is the equal sign. So how can I move the 5m to this side? Well, I can do minus 5m because there, of course, is an invisible plus sign in front there. And we undo addition with subtraction. So if I do it on one side, I have to do it to the other side. So these two will cancel out, and then I have negative 4m minus 5m. If I start negative, I go more negative, I get even bigger negative, so it's going to be negative 9m. Of course, my 2 is still out there, and I bring my inequality sign down. I end up with negative 25 on this side. Just don't forget to bring this sign down. Let's see here. This sign right here needs to always come down, so don't forget to bring it down. Okay, so now how can we move the 2 to the other side? Because this is a constant, this is a constant. We want to get them together on the same side. They are like terms. So I got a plus 2 here. I'm going to get rid of it or undo it by doing minus 2. So minus 2 on both sides. These two will cancel out. I still have a negative 9m. Just don't ever forget to bring down these negatives. When that negative is right there, it still is there. Just because the 2 is gone doesn't mean that the negative in front of the 9 is gone. So we've got negative 9m is greater than or equal to negative 27. Okay, now here's where you have to remember your inequality rules. If we are dividing by a negative, if we're going to divide by negative, then it's going to flip the sign of the inequality. So I am going to divide out the negative 9 because, of course, this negative 9 is being multiplied times that m. So to undo multiplication, we divide by negative 9. So I'm going to divide by negative 9 on both sides, but when I do, what happens, okay, we're going to flip the sign, flip the sign. That's the way that I like to think about it, because these are going to cancel. So m. Now here we go. We're going to flip the sign and flip the sign. See how that negative 27 was a negative 27? It's going to turn into a positive. That's what happens. Both of these things flip. This flips and this flips. So flip the sign, flip the sign when you divide by negative. Okay, so going back over here, I'm going to end up with a positive 27 divided by 9. But how many times does 9 fit into the 27? It fits 3 times, so it's going to be a positive 3. Alrighty then. So that is algebraically how we find our inequality. And sometimes the textbook or teacher that you have may accept that as the answer in full in terms of how you would express it as an inequality. But we're going to, in a few minutes, figure out how to write it using interval notation. But before we do that, we are going to go ahead and write a graph, and we're going to graph it. So there's my graphing line, and I have a 3 here. So I'm just going to go, it's like, if we want to, we could stick a 0 on there just for fun. And here's our 3. And we need to look at our inequality. It says that m is less than the 3. So if it's less than the 3, and it also says it's equal to it. So equal to it means closed circle. Closed circle. That means it could be equal to 3. So we just need to figure out if m is less than 3, are the m's to the left or to the right if they are less than 3? Well, they are to the left of 3. So it would go that direction. So that's the way the graph looks. Okay, so but where is it going over here? Where is it going? What is over here? It stops here at 3, but it's going to negative infinity over there. It's going on forever and ever and ever. M's are less than 3, but we don't have an ending point for them. So that informs our interval notation. So we could never reach infinity. So because we can never reach infinity, we use what I call a soft close, parentheses, and it is going to go to negative infinity, but it is going to go all the way up to the 3, and our inequality sign originally said that it could be equal to it. It can be equal to it. So when it's equal to it, I call this a hard box. The hard box means that it can be actually equal to the 3. So that is how we demonstrate our graph right here. And this is how we demonstrate our inequality in interval notation. So hopefully that was helpful, and we want you to click the like button, and we want you to subscribe to our channel and come back real soon for more math help. Thank you.